Okay, this video we will talk about integration. Integration is very closely related to derivatives, and we'll use the analogy again with our good old friend, the automobile car. We have about a few 100 million cars, so we're very acquainted with cars here in the United States. We'll use the car that it has this interesting and weird feature. What is its feature? First of all, it starts driving from a white line that is on the road from New York City to Monticello, New York. There is a man in the car with a watch, and the watch has 0000. As the car passes the white line, the clock starts running and the car starts going. But here's the funny part. The guy does not push his foot on the gas. Rather, the car has a very interesting relationship to the clock. Whatever says on the clock, that's how many miles per minute he does travel. So, when it says on the clock 1, that means 1 minute passed, he travels at that point of time 1 mile per minute. The clock keeps on moving. 2 minutes passed. Now the car decides to travel 2 miles per minute. 3 minutes are passed. The car decides to travel 3 miles per minute, so on and so forth. After 60 minutes have passed, the car drives now 60 miles per minute. Very fast. It's a fictitious car, as I said. It's all about science fiction, math. It's just more interesting. So we have here some fictitious car. How is he related to derivatives? Very simple. Derivatives, we say that we have the clock, the stopwatch is the same, the car is the same, the white line is the same. They both start from New York City to Monticello. In the first case, we have the time and the distance, and we made up a story that the distance of the car will be the time squared. Time times time, that's how far the car is away from the starting point, from the white line. We were interested to know the speed of the car at any given time. So we want to know, the clock shows 7, what is the speed right now? We know he traveled 49 miles already. We know that when it will show 8 minutes, he will had traveled 64 minutes. We can make some kind of estimation how fast he travels. However, we wish to know exactly how fast, what is his speed when the clock shows 7. That was the video about derivatives. Please watch it before you listen to this one. Now we have a similar closely related question. The car is traveling. We know the time, we know the speed, we do not know the distance. Yes, we know that it's 7 minutes. We know that by minute number 6, by minute number 5, he traveled 5 miles, and 6, he traveled 6 miles. How can we know how many miles he traveled altogether? that we have in our language that's called distance. How far is he from the starting point? That's the unknown in this scenario. In this second kind of car, it's called the first car, the derivative car. This car we call the integral car. They'll give name these cars. Both cars have names. So this integral car has driving a special way, but we do not know the distance. Let's just use some kind of say common sense, or some kind of guess or estimation, or very, very childish estimation. We say like this: hey, let's say the car is right now traveling 10 minutes. We say, hey, right now he's traveling 10 miles per hour, right? So he's traveling already for 10 minutes. 10 minutes. Each minute is 10 miles per hour. I'm sorry, 10 miles per minute. 10 miles per minute, so it's 100 miles. That's the distance. Oh, come on, doesn't make sense. He just, right now, exactly when the clock showed 10, he's traveling 10 miles per minute. And before he was traveling much slower, much slower, much slower, so how can you come up with such a huge number? So we can say like this: okay, let's make an average. When he was traveling 0, he was traveling nothing at all. So let's make it in between. Instead of saying he traveled 100 miles, we'll say he traveled 50 miles. Let's estimate that. And believe it or not, it's a good estimation. But again, here it's good. I can make different scenarios where you cannot use this trick. You need to use some other kind of trick. Totally different kind. I'm just tell you one scenario, and you'll see that you can get much more windy. Make the car a little bit more weird and more unique and more fake. The car will be in such a way that his speed is always the time squared, or the time cubed. So when it is 1 minute past, he's traveling still 1 mile per minute. When 2 minutes have passed, he's traveling 8 miles per minute, because 2 times 2 times 2 is 8. When 3 minutes have passed, he's traveling 27 miles per minute. When 4 minutes have passed, he's traveling 64. When 5 minutes have passed, he's traveling 125. When 10 minutes have passed, he's traveling 10 times 10 times 10 is 1,000 miles per minute. And obviously, any given 7.5 minutes have passed, he's traveling 7.5 times 7.5 times 7.5 miles per minute. Just take a calculator and find it out. Find out how fast he's traveling. So we know exactly in each given time how fast he's traveling. However, we wish to know what's the total distance he will have traveled after going on in such a funny manner for 10 minutes in a row. Now you can say, okay, it's 1,000 miles, and so it's 500. Nah, doesn't seem good. It is not good. Not average. Here it's a total different way how to figure it out. I'll just tell you the answer, and how to figure it out you'll have to wait a long time, get into more videos later on. But let's just give a fast answer for this. You shouldn't go to sleep not knowing where you're up to on the road. You need to know how far you're from New York City. After all, you're traveling already for 10 minutes in this interesting car. You still don't know how far you are. You know all the rules, you know how the car works, but you do not know how far you are from New York City. So I'll tell you, answer is, it is 10 5,500 miles. And the reason, you'll have to wait for the next video. Okay.